Yes, hello everyone. This is lecture 21 on computer networks, and in this lecture, we are going to study application layer. Now, okay, we were studying application layer, and we have completed DNS and we have completed email. Okay, so for DNS, you have to remember properly UDP is used and port number is 53. These are very important points. Okay, and sometimes for DNS TCP is also used, but port number remains same. So DNS uses both UDP and TCP. When TCP is used, when from say one primary server to other secondary servers, we are transferring you can say entire zone file, then obviously TCP will be used because large amount of information will be transferred. Okay, so for that TCP is used, but generally for query for IP address, for URL to IP address. Okay, for URL to IP address, generally we will use UDP only. Okay, mostly UDP is used, but sometimes TCP is also used. Port number 53, you have to remember it. Okay, next for email. For email, we have studied three protocols. One is SMTP for transferring emails. Okay, and its port number is, I think so, SMTP port number 25. Okay, yes, and then we have IMAP 4 for viewing of email, and POP3. Okay, that was message access agent. So POP3 110, binary for 3 is 011, so you just reverse it 110. For IMAP 4, how you will remember the port number? 4, so you will write 4 in the middle. So how you will get 4? 1 plus 3, that is 4, so 143, that is for IMAP 4. Okay, port number you have to remember. Imagine the following, they are going to ask again and again. Okay, next, so email we have completed, and I have told you clearly that from one say for example A is sending email to B. Okay, so from A to mail server, MTA will be used, that is SMTP. Let me write it properly. SMTP one time. Then from mail server 1 to mail server 2, like Google to Yahoo and so on, SMTP is used. And then from mail server 2 to B. Okay, for here we will use POP3 or IMAP. POP3 or IMAP. So generally IMAP is not, POP3 is not used nowadays. IMAP 4 is used. Okay, so it is not used, it is obsolete. IMAP 4 is used. Okay, so 2 times SMTP and 1 time POP3 or IMAP 4 for emails. Okay, I have told you clearly. Now we are going to start FTP. Take the snapshot. I will jump to the next slide. Okay. FTP, so this question have been asking it many times, that FTP is different from all other application layer protocol in the sense that it will make two separate TCP connection. FTP, I think you already know, file transfer protocol, used to transfer file. Okay, file transfer protocol used to transfer files, and it uses two separate connections. Two separate connections. Okay, one is control connection, one control connection, and one data connection. One data connection. Okay, so control connection, I think you have got it. It is used for transferring of commands and so on. I'm not going into commands and all, it is not required. Next is data connection. Data connection is used to transfer the files. Okay, so one control connection and one data connection. So for control connection, TCP is used, port number is 21. For data connection, again TCP is used, port number is 20. So how you will remember? Control means what? It is having more power, because it is controlling everything. That's why it has given higher port number, that is 21. Okay, and data is having less power, or you can say control connection is controlling everything. That's why it is giving a higher number. So it will give lower number, that is 20. Okay, and this data connection is non-persistent. Non-persistent means, for example, you have given command to download one file, then if one file is transferred, then this connection will be released. Okay, but control connection will be there. So for example, if you want to transfer 10 files, then control connection will be there for 10 all the 10 files, but data connection will after transferring one file, it will be released. Then again it will make a connection, then after transferring one file, it will be released. That is the basic meaning of non-persistent. Okay, after transferring file, data connection will be released. Okay, but control connection will remain for entire you can say session. Okay, for entire session control connection will be there, but data connection will keep on establishing and it will be keep on releasing. Okay, so that is the basic meaning of non-persistent, and it is persistent. So these questions have been asked in it many times. Okay, FTP is different from others. Why? Because it uses two separate connections, one for control and one for data. But every other protocol is using same connection for transferring control information as well as data information. One connection is used, but here two separate connections are used. Now, since two separate connections are used, that's why it is known as out of band protocol. Out band protocol. This question have been asked. Okay, all these questions have been asked. So you can think like I am just converting pyqs to lines. Okay, I am just converting all the pyqs into some theory. That is what I am telling you. Okay, so these all questions have been asked. So FTP is out of band protocol. Why out band? Because two separate connections are made. Okay, and why two separate connections? One control and another data connection. Data connection is non-persistent, control connection is persistent. So that means FTP uses both persistent as well as non-persistent TCP connection. Okay, so FTP,
FTP, sir?
Please come again.
FTP is even called as outband.
Because it uses two separate connections.
That I understood, sir. It is outband is another name for FTP, isn't it, sir?
No. FTP is outband protocol. Okay. Others are in-band protocols, but it is outband protocol. FTP uses both persistent and non-persistent TCP connection. Okay. Yeah, persistent is control connection, non-persistent is data connection. Okay, that's it. This is more than sufficient, whatever I have told you. So there are many things in FTP, but we will not study all of them because it is not required. Okay, so you can take snapshot of this, then I will jump to the next slide.
Done, sir.
Okay, so now we are going to start HTTP. Next protocol is HTTP. HTTP is Hypertext Transfer Protocol. Hypertext Transfer Protocol. What is hypertext? Hypertext is clickable text. Clickable text. Okay, so how it will work, let me tell you that. So first of all, you should know that HTTP is used to access web pages from web browser. Okay, so HTTP is used to access web pages from web browser. Okay, next important point is it is used to it is mainly used to access data, okay, from World Wide Web. Access data from www, World Wide Web. Okay, so how it is going to work, let me tell you that. So we have a web browser like Internet Explorer or something. We will have an HTTP client. HTTP client is a, you can say, process. HTTP client. Now this HTTP client will request HTTP server. So HTTP request, or you can say web page request. HTTP request means it is just requesting a web page. It is your HTTP server. Okay, and it will fetch the web page. So this is the basic working. Okay, so HTTP client will send HTTP request to the HTTP server, and then it will send the web page. So directly indirectly you have got the idea that HTTP is based on client server model. So it is a client server application. Take the snapshot. I will jump to the next slide.
Done, sir.
Okay, so the very important point is HTTP is client server application. HTTP is based on client server model, or you can say it is client server application, or rather I should say it is based on, HTTP is based on client server model. Is based on client server model. Okay. Yes, next important point is HTTP does not have any flow error control mechanism, so it will rely on TCP for that. Okay, so HTTP does not have any flow or error control mechanism. Does not have any flow or error control mechanism. So it rely on TCP for that. So directly indirectly you have got idea that HTTP will use TCP at transport layer, and which port number is used? Port number used is 80. Okay, so HTTP uses TCP as transport layer protocol and port number is 80. Okay, port number is 80. Okay, next is HTTP is, see, there is only one connection. I have told you one port number now, so obviously one port, one connection. If I told you two port number, then you can imagine that there are two connections. Like in FTP there were two connections, 20 and 21. I have told you two port numbers, 20 and 21, so that means two separate connections. But here I have told you only one TCP connection, that is with port number 80. So control information and data information, everything will be traveled from one connection, hence it will be in band protocol. So HTTP is in band protocol, that is
The reason is?
no, yeah, please come again.
The reason is, sir?
Same, I'm writing now, HTTP is in band protocol, that is no separate connection. No
Okay.
separate connection for transferring of control information. No separate connection for my voice is clear or not?
It is clear, sir.
Okay, okay. I think some disturbance is coming. Okay, yes.
Maybe I'm from your.
Okay, let me check that out. Okay, yeah, now I think it's fine. HTTP is in-band protocol, that is no separate connection for control and data. For control and data, that is from same connection, control and data flows. Okay, from same connection, control and data will flow. Okay, so that is the basic meaning of it is in-band protocol. Okay, so next is it is okay, take the snapshot.
Done, sir.
Okay, so next is it is stateless protocol. HTTP is stateless protocol. What do you mean by stateless protocol? Stateless means it will you can say every request is an independent transaction. Okay, that means there is no dependency of for example, you have visited say web page number 1. Okay, now you can visit web page number 5, now you can visit web page number 2, and so on, but there is no relation between them. Okay, so directly it means that HTTP does not remember that previously which web page you have visited and so on. Okay, so there is no relation between what was the previous request, what will be the next request, and so on. Okay, so it will treat each and every request as independent pair of request and response. Okay, so you can write down. Okay, if I will write, it will simply waste the time. Please write down. HTTP stateless protocol, that is it treats each request as an independent transaction. That is it treats each request as an independent transaction. Each request as an independent transaction which is unrelated to previous request. Which is unrelated to previous request. Which is unrelated to previous request. So here communication consists of independent pair of request and response. So here communication consists of independent pair of request and response. Okay, so this is client, so this is server. So it will give request and it will send the web page. Next it will send another request, it will send the web page, and so on. So there is no link between what was the previous request, what will be the next request, and so on. Okay, everything is independent pair of request and response. Okay, this is one pair, this is another pair, and so on, like this. That is the basic meaning of it is stateless protocol. Okay, And next important point is server will not maintain any information about client. Okay, HTTP server will not maintain any info about clients. Okay, like when the client log in, which type of web page client has visited, and so on. It will not maintain any kind of information. Okay, in info about client, like when client logged in, or when client or which web page was visited, and so on. Which web pages were visited, and so on. Okay, so it will not maintain any information. Why? Question arises, why it is not maintaining? Because at a time with server, millions of clients can make request, or per day you can say millions of requests will come to the server. Okay, so server will maintain many websites. So if it keep on maintaining information about clients, then obviously memory will be lost na. So that's why it is not maintaining. Okay, so why? Because millions of user may visit website. Okay, why? Because millions of users will visit the website. Millions of clients, I should say like this, millions of client will make connection with server. Okay, so किसकी request fulfill करे, किसकी नहीं, ऐसे नहीं होता. Okay, so it cannot maintain on the information. Okay, so now problem arises. Now we will have a very basic problem, that since server is not maintaining any information, so how server will show the data or the information which is according to your interest. For example, on Amazon you have visited some shoes, then obviously next time you open the Amazon app you will find shoes only. So how this kind of thing is done? Okay, now I have told you server is not maintaining information, so how this will be done? So for that, server will create a special text file which is known as cookie. Okay, and it will drop that cookie to client side. Okay, now this client will store it. Whenever client will make connection with the server, then it will show the cookie. Server will come to know, okay, so he has visited such and such web pages and so on, so I will show them that related queries and so on. Okay, so you have to remember this: cookie is created at server side and it is stored at client side. Okay, and each cookie has a lifetime or lifespan. After that it will be automatically deleted. I will tell you all these points. Okay, don't worry. So cookie is a and very important point. This question I have been asked in GATE. What is cookie? Cookie is a piece of code? No, cookie is a text file. Okay, cookie is a simple text file. Why it is not piece of code? Why not piece of code? Because if piece of code was allowed, then obviously server can send any kind of virus or it can hack your computer and so on. Okay, so that's why piece of code is not allowed, only text file is allowed. Okay, so cookie is just like that. Server, now client will show cookie to the server and server will show the related information to the client. Okay, so directly indirectly, in place of storing information at server side, at client side it will be stored. Okay, so that is the beauty. Okay, so please write down one or two points. Server create a special text file called cookie. Server create a special text file called cookie and drop it on client computer. So whenever client visit the same server and drop it on client computer, so whenever client visit the same server, then it show the same cookie. And hence server shows the content relevant to you. Yes, sir. Okay, so now please write down heading cookie. What is cookie? Cookie is a text file. Underline that, it is very important. Cookie is a text file. Within bracket write not piece of code. Cookie is a text file, within bracket not piece of code, created by server Who has created it? Server. Created by server. And where it is stored? Client side. And stored at client side or client hard disk. And stored in client hard disk. Okay. It has certain lifespan, and after that it is deleted automatically. It has certain lifespan, and after that it is deleted automatically. Okay. And what it is storing? It is simply storing information about content viewed by client on the website. Okay, you can write it. It store information about content viewed by client. It store information about content viewed by client on website. Okay. Take the snapshot. I will jump to the next slide. Okay. So next is HTTP. There are two versions of HTTP. One is HTTP 1.0. Next is HTTP 1.1. HTTP 1.0 was it uses non-persistent connection. Non-persistent connection. But HTTP 1.1 uses persistent connection. Okay. So what do you mean by this? So this question have been asked in GATE. So make some stars over it. Very, very important question. So for example, a web page is having say 4 images. Okay. And obviously there will be some text on the web page. So question in GATE was how many connections will be made? Okay. So for each image, or you can say for each object, one connection will be made. And which will be that connection? TCP connection. And one for obviously for fetching the web page. So total how many connections will be made? 5 connections will be made parallelly. 5 connections parallelly. Okay. So 5 connections will be made parallelly so that everything can be downloaded at the same time at the client side. Okay. So 5 connections will be made parallelly. And in HTTP 1.1, that is the latest version. In this, if you can say web page is having say 4 images, okay, then only one connection will be made, and from that connection only everything will be transferred. Okay. So what do you think? Which is fast? First one or second one?
First one also, because we
yes,
have
yeah. Obviously, first one should be faster because parallelly everything will be done. But no, second one is fast. This one is slow. Why? Because I have told you for TCP congestion control, we have used AIMD, additive increase multiplicative decrease algorithm. So slow start phase. So slow start was initially window size will be 1 MSS, then 2, then 4, then 8, and slowly keep on increasing. Okay, so here obviously slow start phase will be there, so 1 or 2 segments will be transferred. So here slow start, here, and here also. So 5 connections have been made and all of them will be in slow start phase only. Okay, so obviously it will take time, but here only one connection is established. So slowly it first of all it will be in slow start, but then it will come to congestion avoidance phase and window will keep on increasing exponentially. So obviously lot of data will be transferred. Okay, so it is just like that. You have hired 5 buses and all of them are running parallelly, but they are very slow. But this is a very fast car. Okay, so obviously in fast car you can travel a lot of distance. Okay, so 5 connections parallelly, it is slow, but it is very fast. Okay, so obviously load on the server will be less here. Load on server will be less. Why? Because now obviously very small on a very slow rate data will be transferred, but here on a very faster rate data will be transferred. So server has to transfer data at a very faster rate. So obviously load on server will be high. Load on server will be high, and obviously you can think this is the latest version. 1.1 is latest, so obviously it should be faster, and it is the previous version, so obviously it will be slow. Okay. Yes, so this question have been asked in GATE. So how many connections? So they will say 4 images are there on a web page. Then how many connections will be made? 4 plus 1, that is 5 connections. 4 for the images and 1 for the web page itself. Okay, so 4 plus 1, that is 5 connections will be established parallelly and data will be transferred to the client side. Okay.
Yes, sir.
So you can count, and I think the question was in GATE 2020 itself. In 2020, this question have been asked. So how many connections? Okay, so they will say like this: 4 images plus 1, so total 5 will be the answer. Okay, take the snapshot. I will jump to the next slide.
Done, sir.
Okay, so generalize. I will say in HTTP 1.0, HTTP 1.0, if web page has n images, the number of connections will be
N plus 1. N.
yes n plus 1. Yes, n plus 1. Okay, so in place of saying images, they might say objects also. Like objects can be say multimedia kind of thing, like audio, video, and so on. So there are say n objects on the web page, n objects in the web page, then number of connections will be n plus 1. Okay, yes. So take the snapshot. I will jump to the next slide.
Done, sir.
Okay, so now they will ask steps. Okay, so for example, if you have visited some website, okay, so they will ask what are the steps followed. So steps followed to open web page. If you want to open any web page, what will be the steps followed? So first of all, your web browser, okay, let me write it. First of all, web browser will request the DNS. That means web browser will request a resolver for getting the IP address. For example, you have opened say www.google.com / say something, whatever you want, say some index.html. Okay, yes. So first of all, your web browser will request DNS to get the web page, to get the IP address of google.com. So finally you will get the IP address. After getting IP address, now web browser, first of all, web browser has requested DNS. This is the step number 1. Okay, to get the IP address, so for the URL. Now step number 2. Now next step will be web browser will request the TCP to open a connection. Okay, that is HTTP will be requested now to fetch the web page, and HTTP finally what it will ask, TCP for the connection, because I have told you in the previous slides also, HTTP uses TCP connection with port number 80. Okay, yes. So it will finally ask TCP. Okay, so web browser will ask TCP for the connection. Okay, now TCP will request the web page from the server, web page request. Then after it will get the web page, then it will release the connection. Okay, web page request, then and or you can say after getting web page, let me write it like this: web page. Okay, let me write the same way: web page request, then it will get reply from the server, and then it will release the connection, release the TCP connection, because it has get the web page, whatever it has visited. I have told you, each and every request is independent transaction. See this. So request, then reply, then request, then reply. Okay, so one request and reply has been done. Okay, request for the web page and web page has been come. So now obviously connection will be released. Okay, so same is the case here. So connection will be released, and after that web browser will display the web page on the screen. Okay, so these steps have been asked. So first of all, request will be given to DNS. Okay, then web browser will request TCP to make the connection. Why DNS? To get the IP address, to get IP. Now if it has got the IP, then it will request TCP to make connection with that IP address. It will make the connection and it will send web page request. It will get reply from the server, and then it will release the connection, and then finally it will be displayed. Okay.
Yes, sir.
Yeah. So this is for the client side. For the client side. What about server side? So what server will say? So step number 1 will be what? Accept the TCP connection from the client. It is just waiting for the acceptance now. So step number 1 will be accept TCP connection from the client. Then it will get the name of the file requested. Get name of the file requested. Whatever web page it has requested, it will get the name of that. Then it will get the file from the disk. Get the file from the disk. Okay, then it will return file to the client. Return file to the client, and then it will release the connection. That's it. These are the steps followed at server side. So get the name of the file request. That means whatever web page it has requested. For example, index.html. It was the file which has been requested. Okay, so it will get the name. Then it will get the file from the disk. Like it will search in the disk wherever that file is. It will return the file to the client, and then it will release the connection. That's it. This is the server side. Okay, yeah. Take the snapshot. I will jump to the next slide.
Done, sir.
Okay. So next I will tell you, this is all about the application layer, but still I want to give you few important points which are very, very important. So many times question have been asked regarding port number. So you should remember them. So I am in summary I am giving you, okay, port number, protocol, okay, and what is the application. Application. Okay, so port number 20 and 21, they were for TCP. This was for TCP control connection, port number 20, and it was for sorry, 21 was for control and 20 was for data. FTP data and FTP control. FTP control was persistent connection, data was non-persistent. Okay, next is port number 23. Protocol used is TCP, and it is for telnet. Telnet is not in our gate syllabus, that's why I have not tell you about it, but you should know the port number. They might ask. Telnet is terminal network. Okay, terminal network. For remote login, I think you already know these basic things. For remote login, we will use it. Okay, next is port number 25. Port number 25 is again used by TCP. Okay, and it is for SMTP. I have told you, simple mail transfer protocol. Okay, then is the port number 53. 53 I have told you for DNS. So it is used by both. I have told you, na, UDP also, TCP also, and application is DNS. Next is 67 and 68. Two different port numbers. UDP is used and the application is DHCP, Dynamic Host Configuration Protocol. I have told you, na, it is application layer protocol for IP addresses, na. Okay, physical address to logical address mapping. I have told you the very first was RARP. RARP is obsolete. It is not used nowadays. Okay, and then we have used BootP, and then we have used DHCP. BootP is also not used nowadays. DHCP is used. Okay, so I have told you with real life example also. 2 power 16 IP addresses are there with Airtel or BSNL, and entire India is communicating with them. Okay, so that was the beauty of DHCP, Dynamic Host Configuration Protocol. Okay, next is port number 69. Port number 69, it is used by UDP, and the application is TFTP. I have told you, Trivial File Transfer Protocol. FTP uses TCP. See this. FTP uses TCP, but TFTP, Trivial File Transfer Protocol, it uses UDP. And port number is 69. You should remember it. Okay. Then is port number 80. Port number 80 is used by TCP. And what is the application? HTTP. I have just told you. Okay. Next is port number 110. Port number 110 is used by TCP. What is the application? POP3 protocol. Okay, and then we have port number 143, IMAP 4, na? IMAP 4, IMAP version 4. It was also using TCP, and I have told you how to remember IMAP 4. 4 in the middle, then 1 and 3. 1 plus 3 is 4. 143. Okay, so you can take snapshot of this. I will jump to the next slide.
Done, sir.
Okay, so now I will solve few gate questions. Gate 2007 question. So which protocol uses UDP? Direct. Okay, this is the beauty of application. A direct question will be asked. Which protocol uses UDP? Option A, HTTP. Option B, Telnet. Option C, DNS. Option D, SMTP. Which is using? DNS is using UDP. SMTP, TCP, Telnet, TCP, HTTP, TCP. Take the snapshot.
Yes, sir.
Next is gate 2012 question. They are saying transport layer, which transport layer protocol? Which transport layer protocol is used to support email? A option SMTP, B option TCP, C option IP, and D option UDP. What will be the answer?
So TCP?
Yeah, very good. TCP is the answer. Yes, because they have used the word transport layer. So many questions, almost 90% of students take this SMTP, because the moment they see email, they will say, okay, SMTP is the answer. But no, TCP is the answer because they have used properly transport layer protocol.
Yes, sir.
Okay, take the snapshot. I will jump to the next slide.
Done, sir.
Next is 2013 question. They are saying transport layer protocol for real-time multimedia, file transfer, DNS, email. So I'm not writing the options. You can tell me real-time multimedia, transport layer. Again, transport layer. UDP, I have told you many times, for audio video, UDP is used. For file transfer, do not say FTP, TCP, because transport layer they are asking. For DNS, UDP. Generally UDP is used. Sometimes TCP might be used. Okay, but generally UDP is used. For email, TCP is used. Okay. Yes, so you can take the snapshot. I will jump to the next slide.
So we have to write all this for real-time multimedia UDP.
For real-time multimedia, UDP is used. Yes.
It is a match the following kind of question, sir.
Yeah. Match the following type of question.
Sir.
Okay. Next is, so again match the following: DNS, DHCP, IMAP, POP3. 23, 53, 67, 68, 110, 143. So DNS uses 53. DHCP uses, I have told you, both 67 and 68. IMAP 4 uses 143. POP3 uses 110.
Yes, sir.
Take the snapshot.
Done, sir.
Next question. FTP data, FTP control, HTTP, TFTP. 80, 20, 23, 21, 25, 69. So for FTP data 20, FTP control 21, HTTP port number 80, TFTP 69. Done?
Yes, sir.
Okay. So next is, I will make a very important table. It is very important. So I will write all the protocols: DNS, HTTP, SMTP, POP3, FTP, IMAP4. So the very first is DNS is stateful or stateless. So it is stateless. DNS is stateless. HTTP is also stateless. I have told you. This table is very important. Okay, many questions will be solved. SMTP is stateful. POP3 is stateful. FTP is stateful. And IMAP is stateful. Okay, so I think you can link it with real life also. DNS, why stateless? Because every request will be independent. One time you will ask for Google, next time you will ask for Facebook, next time you will ask for Yahoo, and so on. Every time it will be different request. HTTP is also stateless. I have proved. SMTP is stateful. Why? Because first time you have transferred email number 1, then email number 2, then email number 3, and so on. Every email will be transferred like this. SMTP. POP3 is stateful. Why? Because in POP3 actually it is used to retrieve emails. So you will say retrieve email number 1, then retrieve email number 2, then retrieve email number 5, and so on. So states will be saved. Okay, so each and every request is not independent. Okay, state will be saved. Similarly for FTP, similarly for IMAP. Okay, all these are stateful. So stateless are DNS and HTTP. These two are stateless. Rest everything is stateful. Okay, next DNS is using both UDP as well as TCP. Generally it will use UDP only, but exception TCP when from primary to secondary entire zone is transferred and so on, then TCP will be used. For queries, DNS is mainly used for query. For IP address, UDP will be used only. Okay, but TCP might be used. Next, HTTP, it uses TCP. SMTP, I have told you TCP. POP3 TCP, FTP TCP, IMAP for TCP. Everything is used. Everybody is using TCP. DNS is just using UDP. Next is connection. I will tell you about connectionless or connection oriented. Connection. So I will write here. It is connectionless. Obviously, it will be connectionless. HTTP is also connectionless. Next, it will be connection oriented. SMTP, POP3 is also connection oriented. Okay, oriented. Then it is FTP is also oriented. It is also oriented. Okay, so everybody is connection oriented except first two, DNS and HTTP. Both are connectionless. Less everything is connection oriented. Okay, next is persistent versus non-persistent connection. Persistent versus non-persistent. So DNS is using obviously non-persistent connection. HTTP, I have told you 1.0. HTTP 1.0 is using non-persistent, but 1.1 is using persistent connection. Okay, next SMTP is persistent. Then next POP3 is persistent. FTP is persistent, and similarly IMAP4 is also persistent. Okay, everything is persistent. And sorry, FTP control was persistent. FTP was using two connections. Control connection was persistent, but data was non-persistent. Okay. Yes, this is all about persistent and non-persistent. Then port number. Port number I have told you many times, but I will write it again because it is very important. Port number DNS is using 53. It is using 80. SMTP is using 25. POP3 110. FTP is 20 and 21. 20 is for data, 21 is for control. IMAP4 is using 143. Okay. Yes, next is in-band versus out of band. In-band versus out band. So this is in-band. Obviously DNS is in-band, only one connection. HTTP is also in-band. Okay, everybody is in-band. Only one is out of band, that is FTP. I have told you FTP is different from others because it uses two different connections. Okay. Yes, so this is the table. You can take snapshot of this. I will jump to the next slide.
Done, sir.
Okay, so I will next is GATE 2016 question. They are saying stateful application layer protocol. Stateful application layer protocol. Option is HTTP, FTP, TCP, POP3, which is stateful. FTP and POP3, they were stateful. Okay, HTTP was not stateful. TCP, forget about it, because they are saying application layer protocol. TCP is not application layer. Okay, yeah, but for the sake of information, I will tell you, stateful is TCP is actually stateful. Okay, why? Because state will be maintained. Okay, connection will be established. It has a very big state transition diagram, but I have not told you because it is not so important. Okay, and if you have still interest, then on YouTube you can watch my lectures on this state transition diagram of TCP. Okay, but it is not so important. Yes, TCP is stateful. Okay, and stateless. So you have to remember this thing. Whatever is connectionless, that will be always stateless. Okay, so stateless means obviously whatever is connectionless, it will be stateless. So UDP is state connection or less, so it will be stateless. IP is state connectionless, so it is stateless.
Yes, sir.
Okay. So you can take snapshot of this. I will jump to the next slide.
Done.
Okay, next is gate. Okay, I think slides are over. So next is gate 2011 question. So send an email from mail client to mail server. Send email from mail client to mail server. Next is download email from mailbox server to mail client. Last is checking an email in web browser. Okay, so which protocol for which you have to tell me. Okay, so for sending an email from mail client to mail server. Okay, so I think there is no confusion. SMTP. So say for example A is sending email to B. So from A you have to send to mail server 1, from mail server 1 to mail server 2, from mail server 2 to B. So from here to here SMTP, from here to here SMTP, from here to here IMAP 4 or POP3. So send email from mail client to mail server. So this is mail client na, to mail server. So you will use SMTP. From mail server 1 to mail server 2 SMTP. Now from mail server 2 to B. So you have to download email na, from mailbox, from your mailbox to yourself. For that you have IMAP 4 or POP3. So same, download email from mailbox server to mail client. This is the mail client na. So you have to use IMAP 4 or POP3. Next is very important, checking an email in web browser. So you have to remember a small shortcut. Whenever you see web browser kind of thing, immediately blindly you will answer as HTTP. Okay, very simple. So checking an email in web browser, whenever you are checking email in web browser, then obviously HTTP will be used. If you are checking email in some say user agent like your Microsoft Outlook or something, in that scenario you will use IMAP 4 or POP3. Okay, so if you are checking an email in an application, then IMAP 4 or POP3 will be used. But if you use web browser, then immediately you will answer as HTTP.
Yes,
okay.
Sir.
So you can take snapshot. I will jump to the next slide.
Done, sir.
Okay. So last question, gate 2019. Very simple. Which protocol is used to send and retrieve email? Protocol to send and retrieve email. To send, we will use SMTP, and to retrieve email, we will use either POP3 or IMAP4. That's it. Okay. So here we have completed our networking course. That's it. So now I think only one subject is left. That will be your operating system, which I am teaching you. Okay.
Yes, sir.
So if you have any doubts, then you can ask me. Otherwise, we will wind up the class here itself.
Okay, sir.
Okay then. Good night. Bye bye.
Thank you so much, sir. Good night, sir.